Hi everyone, and welcome back to GISC 126, Fundamentals of GIS. So in the last lecture video, I discussed what a data model is and the two different types used in GIS. And if you recall, those two different data models were the vector data model and the raster data model. So in this video lecture, we will look at the vector data model. So the vector data model is a coordinate-based model for representing the world using points, lines, and polygons. So vector data models are useful for storing data that has discrete boundaries, such as county boundaries, country boundaries, land parcels, streets, and so forth. So in the vector data model, objects are defined by points, lines, and polygons. So an example of a point might be a fire hydrant, or a tree, or a crime location. A line could be a river, a road, and polygons can be census tracts, county boundaries, lakes, and so forth. So each object or feature is a single row in a GIS database, and we'll look at that coming up. And then their attributes are information associated with features, and each attribute is a column in a database. So for example, in terms of attributes, if we had a point and it was a fire hydrant, we could have maybe an identifying number associated with that fire hydrant. We could also maybe have when it was last serviced, does it need servicing, and so forth. So those would be attributes about the point. And if we recall from previous lectures, I know this is going way back, attributes are non-spatial data where, for example, the points, the fire hydrant, would be spatial data. So a good way to represent discrete objects, example buildings, so discrete equals constituting a separate, distinct entity. And that's what vector data is all about. So here's an example of vector data model in which the counties, here is Idaho, are represented as polygons. And so I have highlighted Ada County. And you can know this is discrete data because in Ada County, you're in Ada County, you can walk up to the county boundary, and then you're outside of that Ada County. So it is has a defined boundary. You're either in Ada County or you're not in Ada County. And so each county, in this example, has associated attributes about the respective population totals and densities. So again, here highlighted in the cyan is Ada County. And we can open up the attribute table, and we can see lots of different information. So we can look at the population in 2010. We can look at this population per square mile in 2010, population 13, or whatever attributes might be associated. But that's the power of GIS, is not only having the spatial data, but now we can tie in important, interesting attributes about that. So it's much, much more capable now than just making a map. We can do some kind of cool analysis. So points are identified by a single XY coordinate, and they have 0 dimensions. There's no area associated. It's just a point. And points could be many things, as I said. Could be a tree, crime, and so forth. Line features comprise of a series of straight line segments or mathematical curves, and they're one-dimensional, and they have properties of length and location. So there's no area. We're not talking about width. It's just one-dimensional. Polygons features represented by a closed series of polygons, aka areas. So two-dimensional has the properties of area and perimeter. So the previous slide was a polygon data for Idaho's counties. So listed here are several of the more common vector data file formats: shapefiles, coverages, geodatabases, and CAD files. So we'll only discuss shapefiles today because it's the file format you'll be using most in this class. But please read about the other file formats in the readings. So Shapefile is an Esri, and Esri is the company that makes the ArcMap, Arc Pro software that we are using in this course. So shapefile is an Esri file format, data storage format for storing the location, shape, and attributes of geographic features. So geographic features in a shapefile can be represented, as I said, by points, lines, or polygons. So despite its naming indicating a singular file, a shapefile is actually a collection of at least 3 basic files. And they end in a .shp, .shx, and .dbf. And those are the 3 that are required for a shapefile. So they all need to be in the same directory for them to be viewable. So there are many additional files that can be associated with a shapefile, such as a .prg, which is the shapefile's projection information. So I know this is kind of probably sounding a little abstract to you, but just understand there's a shapefile that we can see on the left here, boundary Willamette, but really there are numerous files that make up or comprise that boundary Willamette shapefile. So all shapefiles must have the same name, but will have different extensions. So in this example, we look at the boundary Willamette shapefile on the left. And this is how the shapefile icon looks in GIS. But this shapefile has at least 3 additional files associated with that, and they are the .shp, .shx, and .dbf, which are represented on the right of the screen. Furthermore, notice that the name before the file extension has the same shapefile name, boundary Willamette. If one of those names were accidentally changed, the entire shapefile would not work. They all have to have the exact same name. Obviously, the extension, the .shx, dbf, will vary, but they have to be the same. Therefore, what I'm trying to get at, the crux of all this, is very important never to alter a shapefile name through Windows Explorer. And that means just opening up like your folder and then look at the folder and see the files in there and start changing those. You always want to change shapefiles, the naming of the shapefiles, within ArcGIS Pro or ArcMap, which we'll use later in the semester. So vector data file has several advantages and disadvantages. So the advantages is vector is corrector. That kind of rhymes nice, so it's easy to remember, i.e. it's just more accurate. So you can use vector data to represent a road or a polygon or the location of a fire hydrant much more correctly or accurately than the raster data file format. And we'll get to that why in the coming lectures. It's more intuitive. I guess that's kind of how we view the world, as more discrete as opposed to continuous. There's good analytical capabilities. Requires less disk storage space, and that is because you're only storing these vertexes, the points, and then these little lines. So it doesn't require much disk space. And we'll see how the raster data model uses a lot of disk space, or has the potential to use a lot of disk space. It's kind of, for the meantime, think of a picture and how much file storage space that takes. And then you could also create topology, and we're not going to deal too much in topology, but topology is kind of how these things, how these lines, for example, connect. So you can think of topology in terms of a road network. You have roads, you know which direction those roads are going. You can have associated restrictions. For example, a one-way street, you can only drive one way. So having this topology is important. Think of maybe emergency management response teams, paramedics, fire, police. They use GIS for routing to get to locations. And topology will help because it can tell you which streets to drive on, which streets you can't drive on, which way you can go, and so forth. So disadvantages: for effective analysis, raster data must be converted into a topological structures, time-consuming to design, meaning it kind of takes a lot of time to build these things and kind of plan out what you want to do, and sometimes it's software dependent. Shapefiles, as I said, are kind of Esri formatted, but some of these things can be used across different platforms. On that note, have a great day.